Tutorial sheet 2, question 5. So, an AM transmitter has an output of 24 kilowatts when modulated to a depth of 100%. We've got to determine two things, but first of all, as usual, let's extract the information that we know. And again, we're talking about powers, so first thing is we write down the equation that we know for the total power. We're quite familiar with now, and what this is saying is that the total output power is 24 kilowatts, so PT is equal to 24 kilowatts only when M is equal to 100% or 1. So from that we can work out what the carrier power is. In other words, PC is equal to PT over 1 plus M squared over 2. If we do that, we get that PC is equal to 16 kilowatts. So if we input 24 kilowatts here and M is equal to 1, we get a carrier power of 16 kilowatts. So those are the three bits of information that we need. So part A says determine the power output when the carrier is unmodulated. In other words, when M is equal to 0. So in this case, very simply, PT, write down the equation again. Well, in this case, when M is equal to 0, which is what it's asking for, when the carrier is unmodulated, that just disappears, and we have PT is equal to PC, which is 16 kilowatts from before. Part B is a little bit more, requires a little bit more thought. It says, after modulation to a depth of 60%, one sideband is suppressed and the carrier component is reduced by 26 dBs. Okay, so first of all, the modulation index is 0.6. That's the first bit of information. Then we really need to understand how this equation is made up of the various components that are in the system. So we've got the PT. If we actually break this up, we've got the carrier power plus M squared over 4 times PC plus M squared over 4 times PC. So what we have here is this is the carrier, and these are the individual sideband powers. Of course, you add all that together and you get that simple equation here. So what this is saying is that we are using a modulation index of 0.6. We know what the carrier power is from here. So we've got the information that we need. One sideband is suppressed. In other words, one sideband we can just completely ignore and goes to 0. So it's a single sideband system in this case. Nothing is happening to the second sideband, and it says that the carrier component is reduced by 26 dBs. So we've got to work out what is the power in our reduced carrier in this case, because we're actually suppressing the carrier. Well, what we need to do is rearrange the equation of saying that 10 log the base 10 of power in the carrier over power in our reduced carrier is equal to 26 dBs, because we want to reduce the value of the carrier power by 26 dBs. And so if we work that out, we get that PRC is equal to 40 watts. Okay? So what we need to do now is work out what the total power is. Well, the total power is going to be the power in our reduced carrier, which is our 40 watts, plus our M squared over 4 of our original PC. So we get 40 plus 0.6 squared over 4 times 16 kilowatts. And if you work that out, you get 1480 watts.